Imagine gazing at the stars and discovering something truly mind-blowing. Some galaxies are drifting away from us faster than the speed of light. Einstein told us that nothing can outrun light. So could our cosmic rulebook be broken? Hold on tight, because we're about to challenge everything you thought you knew about the universe. But before we blast off, make sure you hit subscribe and give us a thumbs up if you love unraveling space mysteries. All right, let's dive in and demystify this cosmic conundrum. First, a little history. Almost a century ago, astronomer Edwin Hubble made a startling discovery. Galaxies aren't standing still. They're moving away from each other. The farther a galaxy is, the faster it seems to recede. This relationship, called Hubble's law, is one of the cornerstones of cosmology. How do we know this? When astronomers look at light from distant galaxies, they see it shifted toward the red end of the spectrum, a cosmic Doppler effect. The light's wavelength stretches, telling us those galaxies are speeding away. Basically, space itself is expanding, and that expansion is carrying galaxies along for the ride. Hubble's discovery was so revolutionary that even Einstein took notice. He had added a cosmological constant to his equations to force a static universe, but when the evidence for expansion came in, he called that his greatest blunder. Today, we measure expansion with the Hubble constant, which quantifies how fast the universe grows. Roughly speaking, for every 3.26 million light-years of separation, galaxies recede about 70 kilometers per second relative to each other. So a galaxy 100 million light-years away recedes at about 2,100 kilometers per second. Go even farther out, and these recession velocities add up fast. They will eventually exceed the speed of light. But remember, it's the expansion of space doing the work, not galaxies zooming with rockets. Think of space like a giant loaf of raisin bread baking in the oven. The raisins are like galaxies, and the dough is the fabric of space. As the dough expands, the raisins move farther apart. Notice the raisins aren't propelling themselves. They're just hitching a ride on the rising dough. Similarly, if you draw dots on a balloon and inflate it, every dot moves away from every other dot. There is no special center of expansion. From any raisin or dot's perspective, everything else seems to move away. In fact, every point sees itself as the center of expansion in its own neighborhood. Now here comes the jaw-dropper. Because of this expansion, really distant galaxies can appear to recede faster than light. It sounds like science fiction, but it's reality. For example, current measurements indicate cosmic distances grow by about 0.007% every million years. That may sound tiny, but over 20 billion light-years it adds up. Two galaxies that are currently 20 billion light-years apart would be roughly 1.4 million light-years farther apart in just 1 year. That's an effective speed of 1.4 times the speed of light. Yes, faster than light, and no laws of physics have been broken. You might be thinking, hold on, isn't that impossible? Doesn't that break Einstein's speed limit? The short answer is, it doesn't break physics. There's a crucial distinction here. Einstein's famous limit says that nothing can move through space faster than light in a local frame. But in this cosmic scenario, the galaxies aren't moving through space on rockets. Instead, the fabric of space-time between them is stretching. General relativity, Einstein's theory of gravity, actually allows space to expand in this way. So no physical object ever overtakes a light beam locally. It's just space itself growing. To make this clear, picture two dots on a rubber band. As you stretch the band, the dots move apart, but neither dot is sprinting. The rubber band is just expanding. In our universe, space is that rubber band, and galaxies are the dots. Einstein's cosmic speed limit still holds for motion through space, but it places no limit on how fast space itself can grow. In fact, we don't even notice this on small scales. Your house, solar system, and even the Milky Way aren't expanding, because local forces hold them together. It's only at truly cosmic distances that this stretching dominates. This cosmic expansion has some wild consequences. For instance, imagine a boundary in space beyond which galaxies are slipping away so fast that their light will never reach us. That boundary is called the cosmic event horizon. Right now, it's about 16 billion light-years away. Any galaxy currently farther than this horizon is receding so rapidly that even light emitted from it today will never catch up to us. It's effectively lost to our observable universe. To visualize it, picture sending a flash of light toward one of those distant galaxies beyond the horizon. The space it has to cross is expanding so fast that the light never reaches its destination. In time, more and more galaxies will fall beyond this cosmic horizon and vanish from view. Scientists predict that billions of years from now, an observer in our galaxy would see only our Milky Way and its close neighbors in the local group. All other galaxies will have disappeared. Wild, right? Here's a mind-bending twist. We can still see some galaxies today that are actually receding faster than light. How is that possible? It's because the universe's expansion rate has changed over time. In the first few billion years after the Big Bang, expansion was slower due to gravity's pull than it is today. So when a very distant galaxy sent out its light long ago, it started its journey when that galaxy was much closer. Over the eons, the universe has stretched enormously. But that ancient light has been traveling through space ever since, eventually reaching us. We see it now, even though the source galaxy has moved far beyond. Think about the very early universe for a moment. Right after the Big Bang came a period called inflation, where space itself ballooned insanely fast, far faster than light speed, in a tiny fraction of a second. That extreme expansion smoothed out the cosmos and created the initial seeds of galaxies. Yet it didn't break any laws because it was the fabric of space stretching. After inflation ended, expansion actually slowed down under gravity's influence. But roughly 5 billion years ago, mysterious dark energy took over, causing expansion to speed up again and separate galaxies even faster. One crazy implication: the cosmic structures we see become permanently hidden behind that one-way horizon. There may be regions of the universe we are doomed to never know about. So after traversing all these cosmic facts, what's the verdict on our big question? Is physics wrong if galaxies can recede faster than light? Absolutely not. This faster-than-light recession isn't a glitch in the laws of physics. It's a feature of the laws of physics. Einstein's theory isn't being violated. In fact, it predicts exactly this outcome for an expanding universe. When we say a galaxy moves apart at superluminal speed, we mean the space between us is growing. In any small patch of space, like around our own galaxy, the rules of relativity still hold, so no object locally exceeds the speed of light. The weirdness only shows up on the largest scales of the cosmos. In summary, yes, on grand cosmic scales, space can expand so rapidly that galaxy separations grow faster than light would cover them. But no, there is no contradiction in physics. The universe isn't breaking the rules. It's just revealing how wonderfully strange an expanding spacetime can be. If this cosmic journey blew your mind, be sure to smash that like button and subscribe for more mind-bending space explorations. Thanks for watching, and as always, keep looking up and stay curious.